Okay, guys, so another Algebra 2 review topic, logs. So we are going to do a somewhat speedy review of it. Like I said, most of this chapter is all review of Algebra 2. Okay, recording. So basically, every exponential equation can be written as a log. So let's write this down. Every exponential function can be written as a log. So when we have a log, it's usually in the format of log and then a subscript, then a number equals something else. And basically in this, the subscript is your base. That number next to it, this is called the argument. But really, what I say, it's just the answer. So we call it the argument, but it's really just the answer. And then what comes over here is actually your exponent. So when we take our log and we turn it back into exponential, it ends up becoming base b raised to the y power is equal to a. And you should know how to interchange between them. Oh, Anissa, your last period teacher said you left your phone there, room 301. Did you get that? You could leave class a little early and get it. How about that? She says she has it for you, though. And you should be able to change between these. You should be able to go from a log to an exponential and exponential to a log, depending on what suits our needs for the problem. Does anybody remember if there's no base written, what number is implied as the base? Not 1, no. That was a good guess, though. 10, you got it. So let's write that down. When no base is written, it is known to be a base of 10. So if I just wrote log x, this is the same as log base 10 of x. And that's how you read it, log base 10 of the argument. When the base is e, it is written as, does anybody remember if the base is e, how we write that? So if there's no base written, it's a base 10. What happens if the base is e? It completely changes its form altogether. Anthony? You got it. It is written as ln, and that's called the natural log. So when you have ln, this represents log base e. Okay, so now let's do some practice. I want us to change from logs to exponential. So for this next part, we're going to change from logs to exponential. Do you guys need me to go back up? You're welcome. So starting off simple, we have log base 2 of 8. Now when you write it as a log, you actually don't need to write the equation to make it an equation. If you wanted to, if it made you feel better, you can rewrite this as log base 2 of 8 equals x, but you don't have to. For an exponential, when you change it to an exponential, you need that equal sign, but for the log, you don't. So remember, we have a base of 2. Now, which one's the exponent? Is the 8 the exponent or is the x the exponent? X, you got it. So it's base, answer, exponent. So we have 2 to the x is equal to 8. Hi.
I'm not sure if I say the name right. Mateus?
She gets your AirPod out. I don't get your AirPod out. It's messed up. Okay, so here we get 2 to the x is equal to 8. Now, I know we can do this in our head, but just humor me. If this were a more difficult problem, what would I have you do? Change the 8 to a base of 2. So this would be 2 to the x is equal to 2 to the third, so x will equal 3. Okay, you guys try this one. Log base 5 of 25. Change it to exponential and then solve. So what we should have done is 5 to the x is equal to 25. What does x equal? 2. So I'm going to have log to the 1, a base of 1/4 of 16. So now when we change this to exponential, we're going to have 1/4 raised to the x power is equal to 16. Now remember last class, what did I advise you to do if you had a fraction and there was 1 in the numerator? So like 1 over a number. What did I recommend we do here? Michael?
Make it a negative exponent.
Good. Make it a negative exponent so it's no longer a fraction. So this is going to be 4 raised to the negative first power raised to the x equals 16. So we're going to have 4 raised to the negative x power is equal, I'm going to change 16 into a base of 4, 4 to the second. So we end up getting negative x is equal to 2. So what does x equal? Negative 2. So let's have log base 2 of the cubed root of 32. So we're going to change this into exponential. So we have 2 to the x is equal. Now I want to change this radical into exponential. So this is going to be 32 raised to what power? 1/3. What do you think I'm going to tell you to do now? Change that 32 into what? Into a base of 2. And how can I make 32 into a base of 2? 2 to the 5th power. So we have 2 to the x is equal to 2 to the 5th raised to the 1/3. What do we do with a power to a power? We multiply. So 2 to the x is equal to 2 to the 5/3. So what does x equal? 5/3. Okay, so now that was a quick review of just changing logs to exponential. Now let's talk about some laws of logs, some rules that go with logs. First one is, if I have log base b of 2 things being multiplied, x times y, as my argument. So my argument is x times y. This is the equivalent to log base b of x plus log base b of y. Next one. If I have log base b of x divided by y, so my argument is division, x divided by y, that's going to be the equivalent of log base b of x minus log base b of y. Next one. If I have log base b of x raised to the a power, so my argument has an exponent, that is the same as bringing that exponent to the front and saying this is the same as a times log base b of x. All right, next one, which is sort of the same thing. If I have log base b of the nth root of x, well, isn't that the same as log base b of x to the 1 over n? So really what this is telling us, we know a radical can be written as an exponent, but then if it's an exponent on the argument, where can we bring that? To the front, right? And make it 1 over n times the log base b of x. Should you have these all memorized? Yes. You probably in Algebra 2 went into very specific detail of why this is what it is, but now I'm just doing quick overviews of everything. Okay, so now let's use these rules. We're going to use these rules, and I want us to, in this next section, expand using the laws of logs. And when I say expand using the laws of logs, that means I do not want any products, quotients, or powers as part of the argument. All right, so the first problem I'm going to have us do is log base 2 of 3xy to the third. Okay, so this is, do we all agree this is my whole argument? What operation is between all of these? Multiplication. So this is the same as log base 2 of 3 times x times y to the third. Do we agree? And when the argument's multiplication, I can split that into log what? Go back to your rules. When the argument's multiplication, I could split it into log addition. If the argument's division, I could split that into log subtraction. So this is multiplication, I can split it into log addition. So this is going to be log base 2 of 3 plus log base 2 of x plus log base 2 of y to the third. I'm still not done. What is wrong with this? Timmy?
Exponent on the last one.
Good. Now the exponent on the last one. Was the exponent on this whole parenthesis? No, it was only on this. So when I bring this 3 in front, I'm only going to bring the 3 in front of this specific log. So this is log base 2 of 3 plus log base 2 of x plus 3 times the log base 2 of y. And now we have it fully expanded. All right, next one. I'm going to have log base 2 of x squared minus 5 over 2z raised to the third power. Okay. See the difference. See how this exponent was just on the y, and see how this exponent belongs to the whole argument? So when I move this exponent to the front, I can move it to the front of this whole thing since it belongs to the whole argument. So when I go, I'm going to have 3, and then I'm going to make brackets. And then we're going to have log base 2 of x squared minus 5 minus log base 2 of 2z. How many people think we're done? We're not done. Good. So, even though it looks like we should be able to do more, are we actually done here? We are actually done here because this squared doesn't belong to the whole thing, and the whole argument is x squared minus 5. I can't split up subtraction. So this is actually all we can do here. Are we done here? No, because what's between the 2 and the z? Multiplication. So I can split that into log addition. So this is going to be 3, and then we have our brackets, log base 2 of x squared minus 5 minus, now do I need parentheses? Yes, I do need parentheses because I'm changing it to addition. So this is log base 2 of 2 minus plus log base 2 of z. Why did I need the parentheses here? Why did I need it? Michael?
Because the subtraction means that like the whole thing is on the bottom, but if you don't have the parentheses, the addition would mean it's on the top.
Exactly. So remember, this subtraction means this whole thing was getting divided. If I forget my parentheses here, it's saying just this first part will be divided and that this other part's being multiplied, which is really bad. So now you can, I'm actually fine if you leave it like this, or you can distribute in the negative. If you wanted to distribute in the negative, that's fine. We'd have 3 times the quantity of log base 2 of x squared minus 5 minus log base 2 of 2 minus log base 2 of z.
Do you have to do that though?
You do not. If you gave me this, I'd be fine with it, to be honest with you. Michael, you may. Okay, so now I gave you the laws of logs. The other thing I want to do is recap those shortcuts for logs. So really in this day, I'm like combining probably 4 days worth of Algebra 2 lessons. Because you've already learned this, we're just going through it super quickly. So now we are doing log shortcuts. Okay, so if I have log base b of b, that's actually going to equal 1. And I'll show you the reasons for this. Why does log base b of b equal 1? Well, think about what log base b of b is. This is saying b to the x power equals b. Well, b to what power will give it itself? 1. That's why log base b of b will always simplify to 1. So that's the first shortcut. Log base b of b will always be 1. Next shortcut. Log base b of b to the t is equal to t. So anytime you have log base b, so basically when your base and your argument are the same, it will simplify to the exponent on that argument. So let's see why. If I have b to the x is equal to b to the t, because they have the same base, won't their exponents be equal? So x will equal t. So log base b of b to the t will always be that exponent t. Next one. B raised to the log base b of t will also be t. Will be t. Let me explain why. I'm going to do this with a number because I think it will make more sense. If I have 2 to the raised to the log base 2 of 8, so what we're going to do is we're going to work with this exponent, right? So if we're working with that exponent, we're going to have Right, if we're working with this exponent, we're going to have 2 to the x is equal to 8. Well, 2 to what is equal to 8? 2 to the third, right? So this becomes 2 to the third. And what's 2 to the third power? 8. So what did this say? When I have b raised to an exponential, but it's a log exponent, that means the argument ends up being what it simplifies to. So see how we had 2 raised to the log base 2 of 8. So my base and the base of the exponential and the base of the log are the same, 2 and 2. That means the argument will be the complete answer. So here we had 2 raised to the log base 2 of 8. Our answer was 8. It will always be that. All right, and the last one, which is pretty much the same as C. If I have e to the ln of t, that will equal t. And why is this? This is the same as saying e to the log base e of t. So aren't these the same idea, right? Same base, same log base, so it's going to be the argument. So that equals t. All right, do you think you should memorize these shortcuts? Yeah, you should definitely have these shortcuts memorized. All right, let's do some problems. So I want us to now write as a single log. So I'll give you a second to write it down, and then we'll go from there. Okay. I know I have the 1/5 in the front. I'm going to worry about that a little bit later. I'm going to work within my brackets first. Within my brackets, I see the subtraction. What does the subtraction mean? We can go from log subtraction to division. So I know we're going to change this to division. On the left side, is there anything I can condense there? There's nothing to condense there. On the right side, is there anything I can do? There is. I can pull that 3 in the front and bring it back as an exponent, can I? So this is going to be 1/5 times the ln of x minus 4 minus the ln of x minus 2 cubed. Now, once I've condensed as much as I can on either side of the subtraction sign, and I'm ready to change it back to division, you just pull out 1 ln. You're not going to have 2 ln's anymore. Now it's going to condense back down to 1 ln. Because to get the separation, to get this subtraction, we separated that ln. We sort of distributed it in a way. So now we're going to condense it back down. So this is going to be 1/5, only 1 ln. And that's going to be of our argument, which is x minus 4 over the quantity of x minus 2 cubed. What is our last step here? The 1/5. Now that 1/5, where is it going to go? On the whole entire argument. So do I really need these square brackets anymore? No, I don't really need these square brackets anymore. So that 1/5 is going to go back on the whole argument. So this is going to be ln, and then x minus 4 over x minus 2 quantities cubed. And then that 1/5 is going to go on top of it. So we took an expanded log and condensed it down to 1. Let's try another one. So let's put a star and write this down so you don't forget. When writing as a single log, should only have one log written in your final answer. Is anybody still copying? Okay, let's try this next one. It's going to be a little bit more involved. So now I want us to evaluate. And I'm going to have 2/3 log base 7 of 125 minus 2 times log base 7 of 35. Now, this 2/3, does it belong to everything or just the log base 7 of 125? Just the log base 7 of 125. How would I know if it belonged to the whole thing? What would have to be? We would have had to have brackets or parentheses, right? But since it's no parentheses, we know it just belongs to this one. So I'm going to pull that back as an exponent. So this is going to be log base 7 of 125 raised to the 2/3 power. Minus, can I also pull this 2 as an exponent now? So this is going to be log base 7 of 35 to the 2nd power. Anything more I can condense on the left side? Anything more I can condense on the right side? No. So because of the minus now, I can change this into what? Division. When I now change this to division, how many logs should be written? Just one log. So this is going to be log base 7, and my argument is going to be 125 raised to the 2/3 over 35 raised to the 2nd. Now this is going to take some manipulation. Are we all good so far? Now, 125 raised to the 2/3 based on everything we were doing last class should sort of be like flashing like a hazard light at you. Like, we can do something here. What do you think we could do with that 125 raised to the 2/3 power? Carolyn? The 2's top and bottom?
Yeah,
I cannot do that because they have different bases. So that will not work.
Can you cancel out the 3 in the numerator with like 5 to the 3rd?
That's exactly it. That's exactly what I want to do. Because this is a fractional exponent, my instinct should be, is there any way to cancel out this 3? And we're lucky because there is a way to cancel out the 3, because 125, we can change that to 5 to the 3rd power. So now we're going to have log base 7, and we're going to have 5 to the 3rd power raised to the 2/3 over 35 to the 2nd. These 3's will now cancel. So now we have log base 7 of 5 to the 2nd power over 35 to the 2nd power. See how we manipulated the numerator? Is there any way I could do something similar to manipulate the denominator? Like to make it cancel or do anything? No, there's nothing we could do there. But we can do things to make the simplification smaller. What am I talking about? Well, this is log, do it in black so it's a little brighter. This is log base 7 of 5 times 5 in our numerator. Do we agree? And in the denominator, isn't this 35 times 35? What does that mean? Well, I can take it a little further than this. This is log base 7 of 5 times 5 over 35. Isn't that 5 times 7 times another 5 times 7? So now since it's all multiplication, can I cancel? These 5's will cancel, and these 5's will cancel. So now I'm left with log base 7 of 1 over 49. It said to evaluate. Have I evaluated yet? No. Now once I've gotten it down this small, what should I turn it into to solve? An exponent. Exactly. Now we're going to turn it into an exponent. So it's 7 raised to the x power equals 1 over 49. So what do we get for x? X is equal to -2. You got it. Okay. I want us to evaluate again. I don't know what number this was. 2. Okay. So again, I want us to evaluate. But it's an easy evaluation. Log base 2 of 8. What do I really, really want you to realize here? This is what? 8. Why? It's a shortcut. Isn't this a shortcut? B raised to the log base b of t equals t. So 2 to the log base 2 of 8 has to be 8. Right. So I'm going to make it look a little bit more intimidating. E raised to the ln of 10 plus the ln of 3. Sorry, I got messed up. 2 to the ln of 10 plus the ln of 3. My advice here is work with the exponent first. What do I mean when I say work with the exponent first? What can I do? What am I suggesting we do?
Simplify the exponent.
Simplify the exponent, exactly. So I want to condense this down to 1 log. So we're going to have e to the ln of 10 to the second power plus the ln of 3. Do we agree this is e to the ln of 100 plus the ln of 3? Now what am I going to do with the ln of 100 plus the ln of 3 since I'm trying to condense it? What should I do now?
Like ln 100 times 3.
You got it. We can now change that log addition into multiplication. So this is going to be e to the ln of 100 times 3. And what's 100 times 3? 300. So this is e to the ln of 300. This is a shortcut, guys. Isn't ln log base e? So this is e to the log base e of 300, which is the same as b to the log base b of t. What does that simplify down to? T. So what is e to the log base e of 300? 300. You got it. All right, very last thing we're going to discuss. I know I'm throwing a lot of information at you. Okay, logs are inverses of exponential functions. So let's just refresh our memories in general how we find an inverse. I'm going to take a super simple linear equation. I'm going to ask you to find the inverse of f of x equals 2x plus 3. First thing I'm going to ask you, do you guys all recognize that this is a line, I hope, at this point, right? So what is our domain of this line? All real numbers. What is our range of this line? All real numbers. Who remembers how to find the inverse? The process we take. Tim? Exactly. So when we come to find the inverse, what you do, we know f of x is the same as y. So this is y is equal to 2x plus 3. So when we come to find the inverse, we switch x and y, then solve for y. That's how we find the inverse of any function. So for here, we're going to switch x and y. So I'm going to have x is equal to 2y plus 3. But then what did I say to do? Switch x and y, then solve for y, meaning isolate that y. I'm going to subtract the 3 on both sides. So we're going to have x minus 3 is equal to 2y. Then what should I do? Divide by 2. So we're going to get y is equal to a half x minus 3 halves, right? When you divide by 2 under everything. So the inverse of a line is another line, right? We know that. What about the domain and range? Anybody remember the domain and range of inverses? So this is, you switch. Good, Kate. So the inverse of f of x is going to be a half x minus 3 halves. And we're going to write domain of OG. Do you guys know what OG stands for? Good. The domain of OG is the inverse of the, oh, sorry, not the inverse, is the range of the inverse. Does not want to erase. The domain of the original is the range of the inverse, and the range of the OG is the domain of the inverse. I don't have time to show you this next one. Okay, we're going to stop here. Remind me to show you this last problem that I need to show you next class. But you have more than enough knowledge to do your homework. You're good.